let's integrate the integral that we see right here. It looks hard, but as long as we know the proper method, it should be relatively easy. So to do so, we're going to do IBP, so integration by parts. We're going to set u as cos 2 theta. Du is therefore equal to minus 2 sine 2 theta d theta. And dv is e to the minus theta d theta. And v is equal to minus e minus theta. Notice how dv is always set as the easiest term to integrate, and then the remaining terms are placed as u, and then we take the derivative. Here, e to the minus theta is the easiest one to integrate because its integral is the same as its derivative. Now, recall that IBP is the integral of u dv is equal to uv minus v du. This will help us. Now we can set the integral. So uv, we're going to do minus e to the minus theta cos 2 theta minus 2e to the minus theta sine of 2 theta d theta. This is positive. This is positive because this and this cancels out, becomes a plus sign. Now we can once again use IBP. We can't do anything else because this is a multiplication right here and there's no u sub that we can do. Therefore, we're going to do a second IBP. I'm going to set it in a different color. Once again, we set our dv the easiest term to integrate, and here it's 2e to the minus theta. So 2e to the minus theta, and then we set our u, whatever is left, so whatever remains. Du is going to be 2 cos 2 theta, and v is going to be equal to minus 2e to the minus theta. Now we integrate. Once again, this is the same thing because we don't integrate this part. We integrate this part. So I'm going to put a bracket right here so that's easier. So uv minus 2e to the minus theta of sine 2 theta minus v du. So minus 4 e to the minus theta cos 2 theta d theta. So this was our second IBP. We're going to go back to black, and we can distribute the minus sign to the bracket, so this will become plus 2 minus theta sine 2 theta. And this will remain a minus because there are 3 minus signs that gets distributed. So minus, oops, make it a little better, 4e to the minus theta cos 2 theta d theta. Alright, so now we see that this integral is the same as the integral that we started off with. Therefore, what do? Well, we can set our initial integral as I, because when we did in our work, we can see that this one right here, it's the same as this. Whenever the initial integral pops up again, then you can set it as I always. Therefore, we can rewrite it so that it's clear. We can pull the 4 at the front because it's a constant. See how it's the same thing? Well, if this is I, then we can set this whole thing as I, so that it becomes minus 4i. And we can see that in our initial, this is IBP, UV, UDV, Therefore, let's just write the initial integral. It was the integral of e to the minus theta cos 2 theta d theta minus e but this is equal to I because we set it as I right here. So let's just write it as I. This is I. Now we need to isolate I, but we have another one here. Therefore, we can take this and put it right here. This will become I plus 4I, which will just become 5I, is equal to the whatever is on the right side. And next we isolate the I, and to do so we just divide by 5. So I is equal to a fifth times minus e to the minus theta cos 2 theta plus 2 to the minus theta sine of 2 theta. And there you go. There is our final answer.